Lesson 1, Geometry Review. So we have some terms in this first question that we should be familiar with, but it has been a summer and we might have forgotten some things. So we'll kind of talk about them here for a second. Complement. Do we know what a complement is? Anybody? Well, this is where you say, man, Mr. Wilcox, you look nice today. That's a compliment. No. A complement is two angles that add up to what? 90 degrees. You're on the right track because the next question is, what is a supplement? And a supplement is two angles that add up to 180 degrees. So we should know what times are, 3 times something. And so this is how we begin to write this out, is 3 times the complement of an angle A is 40 degrees. So just so you're familiar with how we're going to write this, is that I don't know what two angles are being added to. I don't know what the measures are. I just know that they add up to 90. So what I'm going to say, 3 times the complement of angle A is 40 degrees, more than the supplement of angle A. Find the measure of angle A. So when we want to multiply the complement of an angle and an unknown, we're going to say 90 minus A. Because I don't know what A is. I just know that A plus something equals 90. Therefore, if I want to know what the complement, the other angle that A and it add up to, I'm going to take A from 90. The other angle is going to be what's left over. Is that correct? And that's a really wordy way of saying that. Do we understand it? So 3 times the complement of angle A. That's what I've written up there. And you can kind of wobble your head up and down. Okay, I get that. All right, now we get to the next part. Is. In math, what do we replace is with? Equals. Equals. Okay, 3 times the complement of angle A is. Okay, 40 degrees more than. Okay, here's the hard part about this, is that are they truly equal? If 3 times the complement of angle A is 40 degrees more than the other side, are they truly equal? No. This side, is it too big or too small? Too big, right? Because it's 40 degrees more than. All right, so I have an option, is that I could either subtract 40 degrees from the left-hand side or do what? Add 40 degrees to the other side. Either one of those is right. But because I've already put the equal sign in here and I'm kind of lazy and don't want to erase, I'm going to do this. Then the supplement of angle A. Well, if the complement of angle A is 90 minus A, what is the supplement of angle A? 180 what? Minus A. Okay, now, what do I still have left to do? Plus 40. Okay? Do we follow me there? Can we see that well enough? Okay? We still have to find the measure of angle A. I still have to solve for A. So now I'm just going through my mathematical procedures, right? What's the first thing you want to do, Michael? Subtract 40 from what? Okay, do you understand which part of what we've written up here are you lost on? The right-hand side. Do we understand how we got the supplement of angle A? Okay. A supplement are 2 angles that add up to 180 degrees. The supplement of angle A, I don't know what angle A is. I just know that A and its supplement add up to 180. So let's take for a second, we know that A plus, let's say, X equals 180, right? And X stands for the supplement of angle A, right? If I wanted to solve for X, what would I do with A? Subtract A, so X equals 180 minus A, okay? But instead of putting X there, the supplement of angle A is equals 180 minus A. The same way the complement of angle A is 90 minus A. Does that make sense? Make a little bit more sense? If you were struggling with it before, do you understand it better now? Got it? Okay. So I'm going to erase that just so it's kind of out of our way. All right, do we understand the plus 40 over here? Okay, let's go back to the reading of it. 3 times the complement of angle A is 40 more than. So there's no, I can't, the only way to have an equal sign here is to balance the equations. So if this side is too big by 40, I either need to subtract 40 from the left or add 40 to the right. I chose to add 40 to the right. Okay, I can't do both. I've got to do one or the other. All right, so from here, what's my next step, David? Distribute what? Okay, so distribute, he says, here and here. So what's my solution? What do I get from all that? 270 minus 3a. Okay? Now, this is just the associative property over here. Can I drop those parentheses? Sure. Okay? Well, what do I do whenever I drop the parentheses? What can I do there? Add 40 to 180. I'm combining like terms. Okay, combining like terms. What's 180 plus 40? 220. And I'm going to finish out the right-hand side by writing minus a. All right, Emily, what do you think? What do you do from there? You want to solve for a. Add a to 3a. Am I still going to have a negative a at that point? Is there a way I could get positive a? I'm not saying that you're wrong, but to make life a little bit easier, if I can keep my variables positive, that's going to help me out a little bit. Katie, what do you think? Add 3a to the negative a. You would still get the right answer, Emily. It just... Okay. All right, so I can bring that down. And because we're in Algebra 3, can we do more than one thing at a time? Can we multitask? Okay, what else could I do instead of bringing everything down and starting over again? Is there anything else I could do at the same time? Subtract 220 from what? From both sides. Okay, specifically from the 270. All right, so what's 270 minus 220? 50. And what is negative a plus 3a? 2a. Okay, final step, manual. Divide by 2. What does a equal? 25 degrees. Okay, we feel like we understand that a little bit. All right, so when you see the complement, you're going to see a lot of these questions kind of show up again and again. You'll see them in the early portion of the lessons. It's going to say things like that. Take notes, you know, specifically, I would say this part right here being the complement of an angle and this part right here being the supplement of an angle. And when you see that more than or less than, know that I have an unbalanced equation. It has to be balanced by either adding or subtracting from the unbalanced side. Okay? All right. Don't know that that's going to let me do that. All right, let's move on to question number 2. Question number 2. This is stuff that we've seen before. What this is this gives us proportions. Okay, and we want to solve for x. Now, there's a couple different ways to do this. I want to see what you know. Proportions are what? Fractions that are equal. Okay? So what would you put on the left-hand side? What kind of fraction? Christian? 12 over 18. Very good. We can do that. Let's see, Dominic, what would you put on the right-hand side? This is where it matters. If I've already done the left-hand side, now I can't do just whatever I want with the right-hand side. Go ahead. X over 24. I just can't do 24 over x, right? All right. And because I want to solve for x, it's a simple what? What is my steps here? Geneva? Cross multiply and divide. 12 times 24 equals 18 times x. Okay? 12 times 24 divided by 18, essentially, right? What do you get? I think I've heard some people say it. 16. Anybody have any questions on that? Did I move too fast? Does everybody understand how to get 16 out of a question like that? Okay, hopefully. Could we have done 12 over x equals 18 over 24? Yeah, that's what you did. Did you still get 16? Still got 16. Great. Okay. Now this, the way I would solve this, just because of the math background that I have, I would consider some things that I would have learned in geometry, but not everybody in here has had geometry, right? Some people haven't had geometry. Okay, so 112 degrees, what you see is this angle right here, and this angle right here. Can anybody from geometry who's had geometry tell me something about those two angles? What are they? They're vertical angles. What do I know about vertical angles? They're the same. A good geometric term would be congruent. Okay? So if I see two angles, if I see two lines that intersect each other, then the angles that are opposite to each other will always, always, always be equal to each other. So I know that y equals what? 112. Okay? Those of you that are in geometry at this time, how many of you are in geometry right now? 1, 2, 3. Okay? The rest of you, have you all had geometry? I know Dom, you haven't had geometry yet. Okay, and you're not in geometry, so that might be a little tough. But the rest of you have had it. You haven't had it, and you're not in it. Okay, so a couple of you haven't had it, and you're not in it. So I'm going to try to kind of bring you along. I would make a note, vertical angles. Of course, we're going to have to identify what vertical angles are. Okay, but vertical angles are congruent. Now, the rest of this, now we know that this is 112 now. Okay, those of you that haven't had geometry aren't in geometry. Do you understand that? Okay, all right. Now I have, I've got x here. Okay, now what's unique about it is that it forms a linear pair with either angle y and angle x form a linear pair, right? If I add them together, I get a straight line. The same thing is true with x and this 112. Now, they have the same measure anyway, but looking at just this, okay, what do I know about linear pairs? What do they add up to? No. 180 degrees. They are supplementary pairs, and we just talked about that. Supplementary pairs are angles that add up to 180. So in order to find out what x is, what am I going to do? Subtract what from what? Right, because what we're saying is that 112 plus x equals 180. If I subtract 112 from x, I'm going to get x. Or sorry, 112 from 180, I'm going to get x. So what is x? 68 degrees. Let me double check. 68 degrees. Okay? Because this is new material, I don't want to just assume that you know everything that I would expect. Okay? If you're confused, if that doesn't make sense to you, let me know. Does that fit? Do we all get that? Okay, even our Algebra 2 people, we get that. Okay, great. All right. Number 4, an equilateral triangle. What does the term equilateral mean? Side length is the same, and it's an equilateral triangle. It has a perimeter of 18 kilometers. How many sides does a triangle have? 3. I didn't pick up on the recording, so I'm not going to talk about what was just said. All right, an equilateral triangle has a perimeter of 18 kilometers, has an area of 9 radical 3 kilometers square. We want to find the altitude of the triangle. Okay, so if they start talking about stuff like this, I'm going to draw it, okay? Now, they told me that I have a perimeter of 18 kilometers. That means side 1 plus side 2 plus side 3 is 18. Now, could I find out what just one side is or what each individual side is? How would I do that? 18 divided by 3 is 6. All right, so as much as I don't like this, and it's 6, 6, 6. Okay, all right, and they tell me that the area is 9 radical 3 kilometers squared. So what's interesting about this question is that there's a lot of different ways to solve this question. What we are trying to solve for, though, is this line right here. Does anybody have problem understanding that that's the line that we're looking for? That's the altitude. And altitude is a line that is going to go from a vertex to the opposite side and be perpendicular to the opposite side. Okay? So a couple of ways to look at this is that one, they told me it was an equilateral triangle, and I know that all triangles have 180 degrees, which means all angles are divided equally, which means all angles of an equilateral triangle measure what? No, that would 60. 60, 60, 60. All right, so it's okay. All right, so there was 60, there was 60. But when we drew this line, what did we do with this 60 that was up here? Split it in half. So what is that angle right there? 30 degrees. So is the term a 30, 60, 90 triangle familiar to anybody? How many of you are familiar with working with 30, 60, 90 triangles? Everybody in here? Okay. When I made this line, what did it do to this side length down here at the bottom? Split it in half. So it made that 3, made that was still 6. The question is that this line right here, we could look at our 30, 60, 90 ratios, right? So we've got 3, 6, and something else. Does anybody remember our 30, 60, 90 triangle ratios? 1, 2, radical 3. 1, 2, radical 3. So is this, and so here it's 3, 6, what? 3, radical 3. Okay, because we're treating this like it was the x. So remember it was x, 2x, x radical 3. So we're replacing x with 3. Does that make sense? You use your shortest side as x. Okay, so that is one way to get 3 radical 3 out of that answer. We have other ways that we could do that, but for sake of time, I'm going with the 30, 60, 90 method. Does everybody in here ring a bell, figuring out something that you couldn't have done? Okay. Okay. Can I erase this, or am I still working on it? Okay. Okay. In this circle, O is the center. The radius of the circle is 7 meters. Okay. Let's see. We want to find the area of the shaded sector. So I know at least in geometry, I think maybe in algebra too, we talked about the area of a sector formula. Okay. So what is the whole shape that we see there? A circle. How do we find the area of a circle? What's the formula? Pi r squared. Okay, so pi r squared. Now, but we don't want the area of the whole circle, right? We want a fraction of it. Now, so we're going to multiply it by a fraction. Let's see. And so what we're going to put on top are the number of degrees of the total shaded sector. But we have 2 of them, so we're going to get 120 over the whole circle, which is how many degrees? 360. Now, what I can do, so the formula that you're using is pi r squared times measure in degrees over 360. Now, we already know what our radius is, though, don't we? Well, so we need to replace this with pi 7 squared, okay, or 49 times 120 over 360. And we're going to leave our answer in terms of pi. $120 over 360 is what, 1/3? Yeah. Right? So that would leave me with 49 over 360, correct? Yes? Does 49 over 360 what is it as a fraction? 49 over 3. 49 over 3 pi meters squared. Is that what you got? Anybody not get that? Anybody not understand? Okay, I'm going to double check. Yeah, because you're getting 49. Yeah, well, it's just going to remain 49 over 3, so, because that won't reduce. Do we get that? Okay, 49 over 3 pi meters squared. I'll leave that there. Move on to our next slide. Hey, Courtney Banner, how are you? That are in here right now? My name's written on all of these. Oh, I see. Okay, hold on. All right. 3 more questions and then you guys can get started. All right, the circle is tangent. Tangent means we've got a line that touches a circle at exactly one point that's going to be perpendicular to the radius of that circle. The circle is tangent to 3 sides of the rectangle. We want to find the area of the unshaded region. Okay, of this figure, dimensions are in centimeters. If we want to find the area of the unshaded region, essentially, what I want you to understand that we're trying to do is this, is we want the area of the rectangle minus the area of the circle. Does that make sense? We're going to try to pull that out. The area that's left is the area of the unshaded region. Well, finding the area of the whole rectangle should be pretty easy, right? How do I find the area of a rectangle? Base times height. What's the base of this? Lexi, what's the base of the rectangle? Base of the rectangle. 7. All right. So, or length times the width. What's the width? 4. So we got 7 times 4. So what's the area of the rectangle? 28. Okay. All right. And they're not, okay. So we got 28 centimeters squared, right? Minus, and we want the area of the circle. How do I find the area of a circle again? Pi r squared. Okay. The necessary part is the radius. Can anybody tell me what the radius is? 2. Because if this whole length is 4, the radius is half of that, right? So we're subtracting pi 2 squared. Well, what's 2 squared? What's 2 squared? 4. So essentially my answer is 28 minus 4 pi, and that's as exact as my answer can get. And so I'm going to write it like this: 28 minus 4 pi centimeters squared. I can't be more exact than that. I could get a decimal, but the decimal is going to be an estimation. You're right. But 28 minus 4 pi is exact. So if your question ever involves radius or pi, and they say we want the exact answer, you're going to automatically solve it in terms of pi. Okay? All right. Number 7 brings us back to question number 1. Okay, so let's see how well we remember how to solve something like number 1. Okay, 2 times the supplement of an angle. Okay, so what do I start off with? 2 times, so 2 parentheses, it says the supplement of an angle. Geneva, what would you write? How do I write the supplement of an angle? 180? It doesn't give you a variable, so you want to use x. Okay, 180 minus x. So 2 times the supplement of an angle. Do we all understand that? Okay. Exceeds 3 times the complement of the same angle by 120 degrees. So it exceeds the other side of the equation by 120 degrees. So what do I need to do? Let's say we want to do it to the left-hand side this time. What would I need to do with the left-hand side? Emmanuel? subtract 120. Okay? Now they should be equal, right? Now it's balanced because it no longer exceeds it. Okay, but what is it equal to? It says 3 times the complement of an angle. So how do I write 3 times the complement of an angle? 3 times what? Ashley?
3 times 9
Minus x. I wanted to say a because that's what we used last time, but we decided to use x this time. Okay, so from there, okay, I'm going to give you some time. I'm going to hit pause on the video, and I want to see if you guys can come up with the answer from there on those steps on your own. Okay, so answers. I got some people with answers. Let's hear some answers. Ashley, what'd you get? X equals 30. Okay, Michael? Okay, so we got 2 people for that. Katie's still working. Emily, Geneva. 30, 30. Okay, over here. 30, 30, 30, 30, 30. At this point, you could be lying to me just because, hey, I got to get some, what? 30? You got 30? Okay, 30 is our answer. Very good. Katie, did you end up with an answer? Did you get 30? I think that's everybody in here, right? I don't think I love Emily, did you get 30? I asked, I think. Okay, great. Everybody got the right answer. So we can move on. What? Maybe? So yeah, the answer is 30. You distribute the 2. You got 360 minus 2x plus 120. So yeah, you guys did it great. All right, now number 8. Number 8 goes back to that other equilateral triangle question. Equilateral triangle this time has perimeter of 72, an area of 144. This time, I'm still going to work this out with you, I think. But I want to show you how to do this based upon the area and not by the perimeter, right? The other time we did it by the perimeter. So let's talk about the area of a triangle, right? How do I find the area of a triangle? Base times height divided by 2, okay? Well, in this case, base times height divided by 2 is 144 radical 3, right? Now, find the altitude. Which variable counts as the altitude in this case? Height, okay? So we know we're going to solve for that. I really need to pick a smaller eraser. But the base is going to be 72 divided by 3, right? That's still going to give me my base. What's 72 divided by 3? 24. So I've got 24 times h divided by 2 equals 144 radical 3. Well, that's going to be what? 12h equals 144 radical 3. Is that correct? Okay. What's 144 radical 3 divided by 12? Well, it should be what? 12 radical 3. Okay. Let me check my answer. 12 radical 3 feet is my answer. So if you don't like the 30, 60, 90 ratio way of doing it, based upon the information they gave me, I just used the area formula, right? So in a lot of these cases, especially with triangles, there's so many different ways to solve these things. It's incredible. Okay? Are we good there? We ready to go? Perfect. I'm going to go ahead and hit stop, and you guys can get started.